Hello everybody, my name is Elton Searcy. I work for Think Big Analytics, and today we're going to go over how to build a Kylo preprocessing feed, a custom one that will feed into standard ingest. Before I start this tutorial, I'm expecting that you've already watched the videos that I've created on how standard ingest works, as well as how to register a new feed to standard ingest. Those are kind of dependencies, but you can still go through this tutorial without those. Okay, so to get started, I'm inside of a Net5 flow and I created a processor group called Workspace. This is where I do a lot of my development. I'll go ahead and create a new processor group and name this custom standard ingest preprocessing. So now that I've gotten in here, there's a few processors that we absolutely need to have in here in our new preprocessing template that we're going to make. To go ahead and get us started, I'm going to take the currently existing version, so the current preprocessing template that Kylo uses for standard ingest. I'm going to bring that template into this workspace, and rather than starting from scratch, I'm just going to modify this one. So again, the name of this template was data ingest, and that's the template you create when you go to create a new standard ingest feed in Kylo. And now with this data ingest feed that we have, there's a couple of things we want to do. For the sake of this demo, the file types we want to handle processing instead of being normal CSV files or being a database file. We're actually going to try to process packaged files. So we need to include a step in our preprocessing to unpackage those files and get them ready for standard ingest. Now you see here I've deleted the connection that bridges database polling and fetch RDBMS data and connects that into the rest of the pipeline, because we're not actually going to use this flow. We're not going to be collecting data from a database, so we don't need to keep that. We are still going to be collecting files from a file system, so we're going to keep this. We're going to push it over a little bit so there's room for these other processors that we need. Okay, so one of the processors that we need is going to be unpack content. What this processor does is it's going to take basically any of these package types, tar and zip are going to be what we focus on mainly. It'll take any of these package types and unpackage them, take any files inside of it, and turn them all each into their own flow file. For setting up this processor, we don't actually need to do anything. Instead, we just need to say use meme type attribute. And I'll explain what that is. So when a file comes in, the type of the file isn't automatically detected. And since in this unpack content we're using the use meme type attribute, well, because it's using an attribute, we need to actually make sure that attribute exists first. And there's a processor that will actually identify the meme type of the files for us. So let's do identify meme type processor. Move these with a little bit more. Okay, so now we have identified meme type. And then we're going to unpack according to the meme type. Notice I haven't actually changed the configurations in either one of these processors. And then unpack content success, we're going to say goes and continues on with the normal flow. Now, there is one thing that we've introduced that will negatively impact the way standard ingest is archiving the original file, making it so that users can re-trigger the same pipeline over and over. because in our pre-processing step here, we're actually taking the original file and modifying it and passing it into standard ingest. Standard ingest is going to take the modified file and it's going to archive that instead of the original file. So what we need to do is we need to add a step into our pre-processing here to archive the original file before we unpack it. So to do that, we're going to take a little shortcut and go ahead and go into standard ingest, and we're going to copy this processor, archive originals, and we're going to paste it down here to failed flow, just so we have them next to each other. And then we're also going to copy failed flow. Just like that. And just now because I have both these next to each other and now affiliated, I can copy them both. Okay, so now go into my workspace, go back to the custom standard ingest pre-processing template we were working on. And now I have both of these processors that I took from, oh, no, I only have one of them. Okay, let me go get the other one. Okay, so now we have a failed flow here. And if you look at both of these processors, they're simple processors. They're just put file processors. Well, one is put HDFS, the other is put file. This will put the file back onto the Linux file system in a error zone, per se. So to make sure that we have all the attributes that we need for these two, let's go ahead and look in them and see what directory they're going to be storing the file in. For HDFS, it's going to store the original archive file in HDFS root archive, category feed, archive ID. Okay, so we need HDFS archive root, category feed, and archive ID. Make sure these are in here. Category feed, archive ID, HDFS, archive root. Okay, those are all there. So we can connect this processor to archive original with success. That's just saying as soon as we get the file and we initialize our feed parameters, we're going to go ahead and archive that original file. And then the other route that it's going to take, which is also success, because you can route multiple successes to multiple cases, is going to identify our meme type and then unpack that file. And then one thing we're going to change in this processor actually is going to be the original, and then I'm going to auto-terminate our original and unpack content. The reason I do that is because I found there's a bug with unpack content in the version of NiFi that I'm using where the original file, when unpacked, doesn't get routed anywhere. So I'm archiving the original manually myself outside of this flow, or outside of this processor's flow. Normally, you'd say original archive, but in this case, we're not actually getting an original file from this processor for some reason. I was testing that before this. Okay, so after we initialize our feed parameters, we have a success on archive originals. And now, if for some reason that fails, we still need to put the file somewhere. So from standard ingest, this was the failure route that all of the different routes in standard ingest went to. That's the failure processors all those routes went to. Let's go and look at it again. So in here in standard ingest, we archive our original, and if for some reason that actually ends up failing in HDFS, which we see here as a failure, then it releases our watermark and it'll go and put that file back on the Linux file system. So we just want to make sure that we do the same things that standard ingest would be doing with these failed flows and with the archive file, so that everything stays in the correct directory structure in HDFS. And everything's more trackable. Okay, so now let's go back down to workspace. Custom standard ingest. Okay. So now we have archive original. Whenever it fails, it's going to go ahead and put file back on the local Linux file system. Let's make sure that our path here, everything exists. Kylo temp base folder. That's one property, or that's one attribute we want to look for. Category feed and feed TS. Okay. Kylo tip base folder, we have that. Category feed, yeah. Okay, but we don't have a feed TS, so let's go ahead and add that. Feed TS, we're going to say equals now to number. So it's just going to take a millisecond timestamp of wherever it is right now, or whatever time it is right now. It's going to set that. We'll apply. Okay, and there's one last thing we need to connect here for unpack content. If this fails for some reason, maybe if we get an unidentified meme type or some sort of file type that's not meant to be unpacked this way, then we'll get our failure and we'll see our failure in Kylo this way. Okay, so I think this is all that we need to do. Let's go ahead and test our flow. Now, keep in mind, since we actually pasted the original data ingest feed in here, none of these parameters are actually real right now. These are all instantiated when you create the feed in Kylo, and Kylo will fill these in with its different application properties and these different properties that were configured when setting up your table with your new data source file. But we can still run our pipeline even though these placeholders are all going to be empty. At least to the point where we unpack our file and have a file ready to be run through standard ingest, which is all we want to test. Sample zip, keep source file, false, apply. Now, I'm going to go ahead and pull open my terminal and just make sure that the file there exists. Okay, we have sample zip. I'm actually also going to copy it. BS is it. Okay, because this processor is going to delete the file when it downloads it. So just to recover, I opened up this file system get file processor, and under file filter I changed the name to be sample.zip for the sake of this test. And I'll go ahead and hit play on it. Okay, we have one file. Alright, that was successful. Now if we look in here, we have category and feed both empty because this isn't a real pipeline, but we have a couple other fields filled in. You'll just notice that these are all pretty much empty because they're configured through Kylo and created new feed. And I'll show you how we do that here in a minute. So we see that's successful. We're going to go ahead and try to archive original. Fortunately, if there's missing fields between forward slashes in this processor, it just resolves it to be whatever directory structure would be minus the empty fields. So if it was, let's go ahead and bring this open. If it was blank, blank, blank number, then this is actually just going to get stored in HDFS into the archive ID, which is just going to be a timestamp, I believe. Let's see real quick. Yeah, so that's just a timestamp. And that worked. So the auto terminate relationship on archive originals, where we see, let me go ahead and pull that up. I'm going to stop the processor first. So the auto terminate on success. And now we'll come down here to meme type and actually practice to see if our code works. Let's do list Q. And here we're just going to make sure that the meme type for our file is actually coming up. Meme type application.zip, or application zip. Alright, so now we'll hit start on this, unpack content. That looks like it worked. List Q. File name sample.csv. That was the file that was inside of our sample.zip. So we know this is a correct file now. Actually, here I'll download it and show you how we can just verify that. So hit download on the flow file and details. Okay. And then we'll go ahead and open up Show in Finder. We'll go ahead and open this with Let's say Sublime Text. It's 130 something megabytes, so it'll take just a second. Okay, and we can see this is a normal file, it's not a zip, so we're good. Into queue. Okay, so now that we have a working flow here with uninitialized initialize feed parameters, because Kylo does that, we can turn this into a Kylo feed template. And that does include this bottom part too, where we have cleanup. So let's go ahead and select it all. Now we're going to do create template. That's what this button does. Alright, so we're going to name this data ingest unpack. To get that registered into Kylo, let's go into admin, and then go into templates, hit your plus sign from NiFi. Then under templates, go into data ingest unpack. We're going to do no table customization. Oh, actually, we are going to do table customization, my mistake. Continue on to step 2. Input properties, we're going to say allow user input required on the file filter, and then we're also going to say input required for the directory, for the drop zone directory. And now over here, first we'll go to initialize feed parameters. Now in this processor, we have to do a few things. Any properties that you check with this checkmark, but do not allow user input on, will be populated by Kylo based on the configuration that it got when the user goes through the table creation process. And because we selected to opt in for that on the select template, customize destination table, all these different properties in initialize feed parameters are going to be populated by what that wizard kind of puts out. So we're going to go ahead and just select all these different properties that we know are going to be needed, like metadata. Okay, we have Kylo, we don't need to edit that. Hive master. Okay. Oh, just a couple more. Metastore, metadata, NiFi home, skip header, Spark input folder, we don't need to edit that. Okay. That's all we need to edit. It's pretty much every attribute with the exception of archive ID. Yeah. Just every attribute that looks like it's using configuration property, you'll need to click the little check mark. Okay, so let's go on to the next step. This is access control. There's no entity management right now. And go on to the next step. Now, because our pre-processing group had 2 output ports, and I'll show that to you just to refresh your memory here. Here, one for standard ingest, and you can see that on the left, standard ingest, and then one here for 2 standard cleanup. We need to route both of these to the reusable templates, standard ingest and standard cleanup. So let's go ahead and route 2 standard cleanup. We're going to click standard cleanup, and for 2 standard ingest, we're going to say standard ingest. Now, the way this is working is these input ports, that's what these are all input port names. These are pre-populated by Kylo from the reusable templates processor group here. So when you register a new processor group, when you register a new reusable template with Kylo, Kylo will actually go and create that whole template in here, and it will create the input ports that lead into the template. So here in reusable templates, we have standard cleanup, and we have standard ingest. We also have regular cleanup port and regular input port, and that's it. Here in Kylo, we can see those are our 4 only options. So we're going to go with standard cleanup and standard ingest for this. And then the icon we're going to use, let's see if we can find something that looks like a zipper. This bug kind of looks like a zipper. Okay. And this is going to help us track the feed leniency. And if you don't know what that is, please look at the Kylo.io website and watch some of those videos. The feed leniency will basically allows Kylo to track different key moments throughout each pipeline and put it in a visual display of that in a graph form. Alright, so now once we have our pipeline here, our template, or rather our feed template is complete, we're going to go ahead and click register. Got it. And now we can create a new pipeline using that feed template. If we go into Feed Manager, we can go to Feeds, hit the plus sign, go to More, and then click on Data Ingest Unpack, which is our new pipeline. Now we're going to say, this is going to be named Food Inspections Demo, because the data that I'm using is some food restaurant inspection data. I'll continue on. Sample zip, var drop zone. We're going to do var drop zone packed files. And before we actually do that, we need to create that directory. Packed. Okay, now we have a file in there in our new packed directory that I just made. I copied a placeholder sample file into the packed sample directory because each time that processor runs, it deletes the old file, so I'm just copying the file in there over and over again until it needs to run. So we'll actually just say packed sample zip, continue on to step 3. CSV, okay, that's fine. We're going to use the sample file that we get out of our zip. So to get to this point, you need to actually unzip your file and submit the sample file in its tabular form, or its comma, or however it's formatted. And click on upload. This will infer all of our different data types. Find partitions. We don't have any partitions. We're going to skip header. Continue on to the next step. Profile. Well, yeah, we'll profile it. It doesn't cost us anything really for such a small file. Then we're going to say sync, and then we're going to put it into Parquet, Snappy, continue, every 5 seconds, and it will feed immediately. Alright, now let's see if our setup worked. While this is creating, we're going to go ahead and navigate to the category that we just created that feed in, which is in test. And now we can see we have food inspections demo. We're going to go into that, and we're just going to see if once this processor starts, it does not have sufficient permissions. Okay, so I just need to change permissions to that folder real quick. Alright, with the permissions updated, it looks like the file rang through. Okay, it went all the way to standard ingest. Let's check it in Kylo, operations, jobs, running. Okay, it's still running. This is an old job. Let me get rid of that. Okay, food inspections demo. Let me make sure that all the properties were set. If you want to check on a execution that already ran through one of these processors, you click on the data provenance of the processor, and you can click on the info of that, and it's basically like looking at the flow file. Now we have attributes. Just make sure every attribute's filled in. Nice, nice. Okay, okay, yeah, looks good. Looks like all our attributes were pre-configured correctly. So now back to Kylo, let's see where this is. Click on the job, jump details, step details. It's now doing archive originals, the second archive originals. This is archiving the CSV file that came out of the zip now. If one idea might be to create a flow, a standard ingest flow that doesn't archive. On previous projects, I've done that, had a standard ingest and a standard ingest with no archiving. Or alternatively, you can in your template before you register it with Kylo, there's a property in here. Where is it? Oh, okay, never mind. I thought there was a flag that told us whether or not we were archiving. So it might be worthwhile to either add an additional standard ingest flow in usable templates to remove archiving from that flow, so that you do it here, or you can add a flag to your pipelines in the initial SVG parameters that says whether or not the archiving should happen in the standard ingest template or not, and you can add a little use case example in there, where if this attribute says I should archive, then archive. If not, then don't. But for our sample, we're not going to go and edit the standard ingest template right now. We're just going to make sure that this pipeline ran completely, and then we'll be done for our demo. Complete. Okay. Now just one last thing, let's check in on the table in HDFS, or in Hive. Let's see if I can get a feed. Here it is. Okay, so now open up terminal, type in beeline, or, well, I mean, if you're on the sandbox, then you can actually type in Hive, which will bring up the deprecated Hive CLI, which you shouldn't use in client projects or anything, but it does still give you access to Hive without having to do all the connection configurations with Beeline. We have to say bang connect. Anyway, let's just do select count from demo, inspections demo. It's going to go ahead and launch the MapReduce job to query our table. Okay, 399 records. Looks good. If you have any troubles, feel free to post in the description below. And I hope this helped you guys. All right. That's it for the demo, and yeah, watch my other videos. All right, bye.